So, this is Justin here. I wanted to do a video about some of the misnomers and just plain wrong things that are circulating around some of the Facebook groups and stuff like that about DNS resolution and why you really should be running your own DNS resolvers. Now, before we go down this path, I'm talking about DNS resolvers. There's two types of DNS servers out there. There's the resolvers, which what we're going to talk about in this video. They're responsible for translating, www.j2sw.com to an IP address, because the whole www stuff is for us dumb humans. The other type that we're not going to talk about in here is authoritative name servers. They're responsible for, hey, when you go out and make a request for, j2sw.com, the rest of the internet knows, hey, these are the authoritative name servers to go ahead and resolve that name. They're the ones that are, they have the authority to return an answer. It's a check and balance system. So in this video, we're talking about resolvers. So one of the problems that goes on is there's ISPs out here who are using Quad 8, Google's DNS 8.8.8.8 and 8.8.4.4. There's also some others, like Cloudflare has, Quad 1, 1.1.1.1. And there's a smattering of others out there. One of the ones I've known for years and years is an old AT&T DNS 4.2.2.2. So what happens and why is it a big deal if you're using these as an ISP and not running your own resolvers? So we'll kind of go through a little bit of an illustrated example here. I kind of threw some stuff in PowerPoint because that was the quickest, dirtiest thing I could come across without spending hours, drawing out Visio diagrams or whatever. PowerPoint fit my needs. So anyway, we have a little happy router here in Indiana, and it's, maybe the head-end ISP router here. So what happens if I'm using Quad 8 on this router? So what happens is it sends a request, and the Google DNS servers are set up as a multicast setup. So when you send a request to Quad 8, the one that answers based upon several algorithms. Some are, the closest one as far as, distance, but a lot of times it's a round robin thing. That's one of their load balancing algorithms. So we're okay if we, send a request and it goes up to, a Google server sitting in Chicago. No big deal. Indianapolis to Chicago is 15 or 20 millisecond, round trip latency. No big deal. And we're not going to see this, on our normal web browsing. The difference between 20 milliseconds and, say, 60 milliseconds, not that big of a deal when it comes to web browsing. But what happens if we hit a Google DNS server, say at round robins to one out in Seattle? Seattle 6 is a big internet exchange out there. So what happens when the request goes all the way out there and all the way back? It's going to be slower. Well, again, not that big of a deal when it comes to, normal web browsing, where we may see a little bit of a delay, but it's not going to be that big of a deal. But what really, when this starts happening and starts, really grinding against your customers, and when we're talking about content networks, we're talking about Akamai, Cloudflare, Netflix, Apple. All of these, content delivery networks have nodes clear across the country in various data centers. And so, I got my little icon here. We'll talk about Akamai. Akamai is very friendly to the IX community, so I like talking about them. So they have a node, say, in Indianapolis. They have one in Chicago. They got several nodes, mini nodes, clear across the country. Pretty much any state, the larger ISPs, data centers, they have nodes. So how do they know which node to serve from? Well, this is where DNS comes into play, and then this is where an ISP who's using only Quad 8 or Quad 1 or something like that as their resolvers, this is where they're doing themselves a disservice. Now, it's not exactly a, oh man, this is evil, you shouldn't be doing that. But if you want the best out of your network, you should be running your own resolver. And here's why. The same request, say it goes out and it hits Google's DNS servers in, Seattle. And it says, hey, I am searching for content on Akamai. Maybe it's a streaming video, maybe it's a movie to download. You're going to really notice problems when it comes to streaming services. Why? Because of that latency. And what happens here? When that request hits the Google server in Seattle here, and it says, hey, Akamai has already said, okay, I know where all my content nodes are in the country or in the world. So when you send a request for that content, and Akamai sees that content come out of Google in Seattle, it's going to say, oh, okay, via my own special sauce, one of the things I look at that tells me which node to serve from is where has this DNS request came from, as far as, there's several things they do. They do, how far away is it from me in milliseconds. So it does a quick on the fly and says, okay, I can serve it out of a data center here in Seattle, probably just, down the hall. But it also looks at, the DNS. It says, oh, I know where, this particular Quad 8, I know that it lives in Seattle. So I know my nodes in Seattle. So I'm going to deliver it from the closest node in Seattle. Well, that's okay. But if you're clear over here in Indiana, now all of a sudden your streaming traffic, if we were streaming it from Chicago, remember we're 20, 30 milliseconds away at Chicago. But if we're serving it out of an Akamai cache node in Seattle, now all of a sudden we're 60 or 70 or 80 milliseconds away, and we have a whole lot more traffic, pipes, all this stuff to go through between Indiana and Seattle. So it's not an ideal situation. Now, where does the resolvers come into play? So let's go back to our little router here in Indianapolis. Now, if the ISP here is running its own DNS server, all these cache nodes know that, hey, that DNS server, when I get requests from that DNS server in Indiana, I know that it's in Indiana. Just like the one in Seattle. When I get a request from a Google server in Seattle, I know that that server's in Seattle. Same thing for Chicago, New York, stuff like that. Through their special sauce, they know where these servers are, hitting them from. So let's go back to Indiana here. If this ISP is running their own resolver, when they do a request, it's going to go to its local DNS server, and that DNS server is going to use what they call route hints. It's going to go out and look at, hey, where does this content actually live at? It's not going to rely on somebody else. It's going to go to the authoritative root name servers and say, hey, I have a request for this. Where do I need to go for it? So if everything's working right, it's going to go to Chicago. Our little Google sign here now is Chicago. It's going to go to Chicago and serve content out of Chicago. Now, if we have nodes in Indianapolis, it's going to serve the traffic out of those nodes in Indianapolis. Now, why is this important? It goes back to the latency. It goes back to, the shortest path between you and the content. And the less things you have in between, the less stuff you have for congestion, overloaded routers, overloaded backbone networks, that sort of thing. It's if you've ever done a trace route, a good trace route is less hops, which means you're not going through as much stuff. So if now say your Netflix stream, if you can get 3 hops away from your Netflix stream, it's going to be better than 15 hops away, because now you're probably going through multiple providers. You don't know what their networks look like, and it can be, less than optimal. But at the same time, it could be a great experience because you're hitting, all these great providers that have, unfettered backbones that aren't full, and their routers are performing optimally, and there's no fiber cuts. But, this is the real world. So, that's kind of a quick. We're at I don't know what we're recording here at. We're at 10 minutes. So in a quick 10 minutes, that's why you need to run your own DNS resolvers. It lets the content folks on the network or on the internet as a whole know where you are. So if they know where you are, they can optimally choose the closest content network or content distribution box or whatever you want to call it. They can choose the closest one to you and serve you traffic out of that. So the whole goal of any internet provider is I want to be able to provide the fastest internet I can to my customers, and this is just one way of doing that. So I hope that clears up some of the misconceptions, and I'm not saying that running Quad 8 is evil. It's just not optimal. And if you're an ISP looking to get the squeeze every ounce that you can out of your network, run your own DNS resolvers.